All right, so in this problem, we have a rectangle bounded by the x-axis and a semicircle. So bounded means like boundaries. So like it can't go past that little half circle here. All right, so it's bounded by this x-axis and the semicircle. So the rectangle could look like how it is in the picture, but it could also, look like this. It could also look like this. It could also look like this. All right, an infinite amount of ways it could look, as long as its vertices lie on the semicircle and the x-axis. All right, so the picture just gives you like one representation of how it would look. All right, so we need to find the area. So area, why does that keep happening? I'm trying to get rid of this little watermark here. Sorry. Bothering me more than it should. All right, we're just gonna live with it. So anyway, the rectangle bounded by the x-axis and the semicircle, and they give you the equation for the semicircle. Write the area of the rectangle as a function of x. So we know area as a function of base and height is area equals base times height. So like this is the base and that is the height, right? But we don't want it as a function of b and h. We want it as a function of x. So we need to express the base and the height in terms of x. So the base, all right, we'll do the base in orange so it really pops. The base is this part, which is going to be x, like wherever this point is. Like if this point was over here, then this right here would be the x coordinate, all right? So as it is in this picture, like this length right here is the x coordinate of this point, and this is also the length of the x coordinate of that point. All right, so the base is really going to be 2x of this rectangle, right? Because it's got like the base is on two sides of the y-axis. If you think back to doing coordinate proofs in geometry, a lot of times we would place the rectangle on the origin, so that if this was like the point xy, then you know that this length was x and this length was y, because it's positioned in a way where you start counting, from one side. So that worked out nicely. But in this case, it's not like cornered at the origin, right? It's kind of centered over the y-axis. So that's why our base in this case will be 2x, all right? So just a quick flashback to geometry. And then the height, all right, the height is going to be just the y-coordinate. It's the distance that this point is from the x-axis. And we know that since it's on the semicircle, that the y-coordinate we can express as 36 minus x squared. So that's going to be our height, root 36 minus x squared. And so our answer for the area as a function of x is, that's it. It's given right here. Bang. All right, we can't really simplify that anymore. 36 and x squared are perfect squares, but 36 minus x squared isn't a perfect square. It's a difference of two perfect squares, which we know would be like 6 plus x times 6 minus x, which is not a perfect square because those are two different factors. All right, so there's that part. And then graphically determine the domain of the function. So remember at the beginning of the video, I drew all the different ways that this rectangle could look. So if we think of like the different ways it could look, all right, it could be like the smallest it could be would be like a x coordinate, like right to the right of the y-axis, right? So it could look like that, but x has to be greater than 0, because if it's 0, then you don't have any base length, and if it's like less than 0, then it just doesn't make sense, because then if this point is like less than 0, now we don't really have like a rectangle anymore. All right, so you need a point on either side of the y-axis. So if x is positive, that ensures that. And then the maximum it could be would be like a really wide rectangle like this, where x is just less than 6. It can't equal 6 because then you don't have a rectangle, you just have a line. So that would be the domain of x. All right.